Hello, and welcome back to the final IB Math speedrun for today, which we're going to be finishing up chapter 8.1 with volumes of revolution. So let's jump right in. So we already know how to find the area under a curve by getting the integral between point A and point B, but what we don't know how to find yet is the volume of revolution. Well, what is a volume of revolution? It's when we rotate this area 360 degrees, or 2 pi radians, around the x-axis or y-axis. Well, what shape do we get? Like in this case, we would get something that looks like this, and we want to find the area of this shape. So how do we do that? So if it's around the x-axis, what we can do is we need to get, well, the circle formula. So this is pi y squared dx of the curve. And so, like, say if our curve is x squared plus 1, no, wait, that's not going to go under, x squared minus 1 between negative 1 and 1. This means we have to get the integral of pi, well, we usually put pi outside the integral, of 1 and negative 1 of x squared minus 1 squared dx. And so we would have to solve this in order to rotate it around. Now, what about the y-axis? Because we can also rotate functions around the y-axis. So in this case, we actually need to get pi of the integral of x squared with respect to y. So in other words, we have to put x squared in terms of y, which is very interesting. So the best way to learn about this is to jump into some questions. So let's do that right now. I guess I'll just do the odd ones. So first, find the volume of the solid formed when the graph of the curve y is equal to the square root of x in the interval 1 to 4 is rotated 2 pi radians around first the x-axis and second the y-axis. So to find the rotation of the x-axis, we need to, around the x-axis, we need to set this limit of 1 to 4 pi of square root of x squared, since y equals square root of x dx. So this will be equal to pi times 1/4 of x, 1/2 x squared, since we have to integrate. And so this is equal to pi times 1/2 times 4 squared is 8, minus 1/2 times 1 squared is 1/2. So this is equal to 15 over 2 pi around the x-axis. So next, we need to do it for the y-axis. So how do we do that? Well, we need to express x in terms of y. So in this case, x is equal to y squared. So we need to get the integral of x squared in terms of y. So this is equal to y to the 4 dy. And we also need to convert these limits from x values to y values. So y is square root x. These are for x, so we have to square root both of them. So this is going to be between 1 and 2. And so this will be equal to pi between 2 and 1 of 1/5 y to the 5. And so this will be equal to pi times 2 to the power 5 is 32, so 32 over 5 minus 1/5. So this should be equal to 31 pi over 5. Yeah, so that's correct. So next, we need to find the volume of the solid formed by rotating the region enclosed by the graph of the function and the x-axis through 2 pi radians around the x-axis. Okay, so the first one is y equals 1 minus the square root of x in the interval 1 and 4. Okay, so we have pi y squared dx, y squared being equal to, is this 1 minus 2 square root x plus x dx, and the limits is 1 and 4. Okay. So this is equal to pi times between 4 and 1 of x minus remember we can rewrite this as x to the power of 1/2. So this will be equal to 4/3 x to the 3/2 plus 1/2 x squared. So if we find this is pi times 4 minus 4 to the 3/2, so 8 times 4, so minus 32 over 3 plus 8 minus 1 plus 4/3 minus 1/2. Yep. So we get pi times, this would be minus 28 over 3. Let's just put it into a calculator. Actually, no, let's not. So let's convert it all over 6. So this is 24 over 6 minus 64 over 6 plus 48 over 6 minus 6 over 6 plus 8 over 6 minus 3 over 6. So this is equal to pi times 7 over 6 pi. Okay. I mean, sorry, 7 over 6. So this is simply equal to 7 over 6 pi. Nice. Okay, on to the next one, where we have y is equal to tangent of x between 0 and pi over 4. So to rotate this around the x-axis, remember pi over 4, 0, y squared, which is tangent squared x dx. So we now need to integrate tangent squared x. So this is going to be by parts, probably. Let's think. This is tangent x squared. Let's try by parts. So this is equal to integral. No, sorry. If we label u is equal to 10x squared, then u prime is equal to secant squared 2 secant squared x tan x. Yeah? V prime is equal to 1, v is equal to x. So this is equal to x tan squared x minus the integral of vu prime. So this is 2x secant squared x tangent of x. We can feasibly integrate this, can we? Oh, what am I doing? Wait. I think I'm overcomplicating this. Yeah, I think I've just overcomplicated this. Let's erase that. So we need to use the identity that tangent squared x is equal to, I believe it's secant squared x. Yeah, it is secant squared x. So this is equal to 1 minus secant squared x is 1 plus tangent squared x. So this would be secant squared x minus 1. dx. So this will be equal to pi times the integral between pi over 4 and 0 of tangent x minus x. So this will be equal to the pi times the integral of, well, that's 1 minus pi over 4. Yeah, it's just 1 minus pi over 4. So this is 4 minus pi times pi over 4. Yeah, that's correct. Okay, on to the next one. Well, we have another one actually. So this is y is equal to 1 over square root x plus 1 between the intervals 0 and 3. So we have the pi of 3 and 0 of 1 over x plus 1 squared, so this is 1 over x plus 1 dx. So this is, okay, so this is simply going to be pi times 3, 0 of ln x plus 1. So this will be equal to pi ln 4 minus pi, but then the thing is, 0 plus 1 ln 1 is 0, so this is just going to be pi ln 4. Yeah, it's correct. So it's just pi ln 4. Okay, on to the next one. We have find the volume of the solid of revolution when the graph of given function is rotated 2 pi radians around the y-axis between the given lines. So we have y is equal to, I think that means x, is equal to 2 sine y. Between y equals 0 and y equals 2. So we have the integral between 0 and 2 of 2 sine y squared, so 2 sine squared y dy. What identity can we use here? So we can definitely use the fact that this is equal to 2, 0 of 2 times cosine squared y minus 1 dy. So this is equal to 2, 0 of 2 times cosine 2y, 1/2 cosine 2y minus 1/2 dy. So this is equal to the integral between 2 and 0 of cosine 2y minus 1 dy pi. So this will be pi times sine 1/2 sine 2y minus y between 2 and 0. So a bit weird limits though. This would be what, pi? Oh, so this is, sorry, this is 4 sine squared y. Maybe that was it. 4 cosine squared y minus 1. 2 times 1/2 cosine 2y minus 1/2. So this is 2 cosine 2y minus 2. So we have here just sine 2y minus 2y. But then sine 4 doesn't exist. So this is a pretty bugged question. I'm just going to do the next one since there's an error in the question. So next is x is equal to tangent of pi over 4 y between y equals 0 and y equals 1. Okay, so we have pi times the limit between 1 and 0 of tangent squared pi over 4 y. So this is all cool. Again, use the identity that this is equal to the square integral 1, 0 of secant squared pi over 4 y minus 1 dy, all times pi. So if we integrate this, it should be equal to pi between 1 and 0 of 4 over pi times tangent pi over 4 y minus y. Is this 4 over pi? Yeah, it is. It is 4 over pi, isn't it? Yeah. So this is pi between 1 and 0. So tangent pi over 4 is 1. So this is 4 over pi minus 1. And then tangent 0 minus 0. So this is just 4 minus 1 over pi. Oh, 4 minus pi. Sorry, 4 minus pi. So yeah, this should be the correct answer. Okay, on to the next one. Find the volume of a solid that is obtained by rotating the curve y is equal to arc cosine x. 0 is less than x is less than 1 through 2 pi radians about the y-axis. Okay. So, in other words, we need to rotate the curve x is equal to cosine y. around the y-axis between 0 and 1, which is simply the pi times x squared. So this is cosine squared x, cosine squared y. Why have I written x there? dy between 1 and 0, which is equal to 1, 0, and then we can use 1 minus sine squared y dy, which is equal to the limit between 1 and 0 of 1/2 plus cosine 2y, I believe, plus 1/2 cosine 2y dy, pi times all of that. So this is equal to pi times 1/2 y plus 1/4 sine 2y. So this is equal to 1 times 1/2 y, 1/2 pi over 2, plus sine 2, wait, sine 2 doesn't exist. What in the world? What are these limits? Oh, 0 is less than x is less than 1. Oh. So this is actually pi over 2 and 0. Okay, which makes more sense. So this should be pi over 2 and 0, I believe. Yeah. Oh, wait, no, this is 0 and pi over 2. Anyways, same. So we have pi squared over 4 minus 0 plus 0 minus 0. So it's just pi squared over 4. So that is the answer. Okay, lastly, we have the question, find the volume of a solid that is obtained by rotating the finite region enclosed by the curves y is equal to 1 plus ln x and y is equal to tangent of x over 2 through 2 pi radians around the x-axis. So this is like a combination of what we've been doing, so we need to subtract the 2, so 1 plus ln x minus tan x over 2 is equal to 0. And we need to find where this equals 0. I mean, the only obvious point I can't think of any obvious points, so we're going to have to Desmos this. So we have 1 plus ln x minus tangent of x over 2 is equal to 0. So as you can see here, there are 3 roots. There are infinitely many roots, but I assume they just mean the region here. So because if we plot 1 plus ln x and tangent of x over 2, I assume they mean this region here between 0.467 and 2.099. So if we integrate this, we need to integrate pi times this squared. Or actually, hold on. If it's the difference between two curves, we can just subtract them. Yeah, we can just subtract the squares of both curves. So actually, it's not that. It's just 1 plus ln x squared minus tan squared x over 2 dx. So this is equal to the integral of 1 plus 2 ln x plus ln squared x minus tan squared x over 2 dx. So if we need to integrate this will be equal to x, 2 ln x. If we integrate 2 ln x, this should be I believe x ln x minus ln x. Because I mean we can use, what's it called? Yeah, it's just x ln x minus x, right? So it's just plus 2 times x ln x minus 2x plus, and then we have ln x squared, which is equal to well, I guess I'm not sure, so we can say, can we integrate it by parts or do we substitute? No. Let's substitute. So let's just get ln squared x dx. So we have u, say say u is equal to ln x. So u squared is equal to ln x squared. And so du over dx is equal to is equal to, well, if we integrate it via e to the u, then we have du e to the u, sorry, I mean this should be on this side, of course, it's equal to d to the x. So we have u squared e to the u du. So we can do this by parts now, because we have u is equal to u squared, u prime is equal to 2u, v prime is equal to, sorry, it's a bit confusing that I'm using the same notation. So that we have here e to the u squared, minus the integral of 2u e to the u. So by parts again, so this would be, so we end up with u squared e to the u minus 2u e to the u plus e to the u, I believe. Plus 2e to the u. So this would be equal to x ln squared x minus 2x ln x plus 2x. Okay, interesting. So we just have to add x squared ln x minus 2x ln x plus 2x. And then now we have to integrate tan squared to the x over 2 dx, which is actually not that hard anymore, because that's secant squared minus 1. This is secant, oh, come on, load. This is secant squared x over 2 minus 1. So this is equal to, if we integrate this, this is minus 2 tan x over 2 plus x. So let's combine like terms. I think we have quite a few. So first, anything with ln x in it. So these two actually cancel out. That leaves us with x squared ln x, x minus 2x plus 2x plus x, so we have 2x minus 2 tan x over 2. And then between what limits was this? Oh, we had the predefined arbitrary limits. So this should be equal to pi times 0.467. So I'll just do this individually for both. So 0.467 and 2.0.99. So for 0.467, this is 0.467 squared times ln 0.467 plus 2 times 0.467 minus 2 tangent 0.467 divided by 2. So I'm getting this equal to 0.292, and then for this one, we have 2.099, so 2.099 squared ln 2.099 plus 2 times 2.099 minus 2 tan 2.099 divided by 2. So this is around 3.982. So if we have this minus 0.292 and then we multiply this by pi, I'm getting something like 11.59, which is weird. This is a big number. And the book says, yeah, 3.58. The book says something different. I wonder if it's this 2x here, because this could be a mistake. This x. Secant squared x equals... Yeah, no, it's plus 1 though, so... Let's check with decimals. So we need to get the integral between 0.467 and 2.099 of 1 plus ln x squared minus tangent squared x over 2 squared dx. All of this should be dx. Yeah, that's a massively smaller value. Oh, where did we go wrong? Wait, this should be ln x squared. That could be a problem. Let's try it again. 2.099 squared yeah, I think I messed it up. Wait. Yeah, see, it's x ln squared x here, not x squared ln x. So that's probably what's causing our issues. Sorry about that. Yep. So I wrote here x squared ln x, not x ln squared x. It should be this. So let's try again. 0.467 ln 0.467 squared plus 2 times 0.467 minus 2 times tangent 0.467 over 2. So this is around 0.729. And then for the other one, we have 2.099 times ln 2.099 squared plus 2 times 2.099 minus 2 times the tangent of 2.099 divided by 2. So this is this is only 1.869 now. So this, if we subtract the 2, we end up with something like 1.14. So this is 1.14 pi, which is approximately equal to 3.583. So yeah, now this is the correct answer. So yeah, I hope you enjoyed the speedrun, and I hope you learned along the way, and I hope to see you in the next one. See you then.